Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how the Emirates Mars Mission has uncovered a mysterious new, patchy proton aurora on the Red Planet. The Emirates Mars Mission, or EMM, the first interplanetary exploration undertaken by an Arab nation, has made first observations of a new type of proton aurora around Mars. The proton aurora captured on Mars by the Emirates Mars Mission are comparable to the aurora that's visible near Earth's North Pole. In simple terms, the northern lights occur on Earth because of the solar wind getting attracted by Earth's magnetic field and eventually colliding with atoms in the atmosphere. According to the UAE Space Agency, this new patchy type of Martian proton aurora is formed when the high-speed solar wind directly impacts Mars' dayside upper atmosphere and emits ultraviolet light as it slows down. The discovery of the aurora was made in snapshots of the dayside disk obtained by the Emirates Mars Ultraviolet Spectrometer, or EMUS, which observes the planet's upper atmosphere and exosphere, scanning for variability in atmospheric composition and atmospheric escape to space. We've seen emissions at these wavelengths before, thanks to proton aurora studies by NASA's Mars Atmosphere and Volatile Evolution mission. But these EMM and EMUS images represent the first time we've had a global view of spatial variability in proton aurora at Mars, and the first time we've been able to unambiguously observe this patchy structure, said EMM science team member Mike Chaffin. We know that these wavelengths are only emitted by the hydrogen atom, which tells us that super-energetic hydrogen atoms must be present in the atmosphere in order to produce the auroral emission. What we're seeing is essentially a map of where the solar wind is raining down onto the planet, he added. The aurora manifests as bright regions scattered across the dayside of the planet in two ultraviolet wavelengths associated with the hydrogen atom. Under normal conditions, the dayside disk of the planet at these wavelengths is uniform, and the planetary brightness results from hydrogen atoms scattering sunlight. When the aurora occurs, small regions of the planet become much brighter at these wavelengths, signifying intense localized energy deposition in the atmosphere. EMM's science lead, Hessa al-Matrushi, opines that the latest discovery adds a new kind of event to the long list of those currently being studied by EMM and challenges the scientific community's existing views of how the proton aurora on Mars' dayside are formed. The EMM HOPE probe has so far uncovered many unexpected phenomena that extend our understanding of Mars's atmospheric and magnetospheric dynamics. These new observations, combined with MAVEN data, have lifted the lid on entirely new possibilities for scientific research, it was added. Martian proton auroras were originally discovered by NASA's MAVEN and subsequently found in data from ESA's Mars Express mission, but most of these previous observations show uniform auroral emission across the dayside of the planet. However, the latest observations by UAE's Mars mission is able to unambiguously reveal small-scale spatial structure. Scientists from both teams now believe the patchy aurora can only be produced by plasma turbulence in the space surrounding Mars. Whether we'll see anything as spectacular as what we've already got is anyone's guess, but I'm hopeful. Hope continues to far exceed our expectations for scientific discovery, and I can't wait to see what we learn next, said Chaffin. The Emirates Mars Mission is the culmination of a knowledge transfer and development effort that started in 2006. The process saw Emirati engineers working with global partners to develop UAE's spacecraft design, engineering, and manufacturing capabilities. Known as HOPE, the probe is a fully autonomous spacecraft, carrying 3 instruments to measure Mars' atmosphere. Weighing some 1,350 kilograms and approximately the size of a small SUV, the spacecraft was designed and developed by MBRSC engineers working with academic partners, including those at the University of Colorado Boulder, Arizona State University, and the University of California, Berkeley. The Emirates Mars Mission is studying the Martian atmosphere and the relationship between the upper layer and lower regions. The Hope probe's historic arrival at the Red Planet coincided with a year of celebrations to mark the UAE's Golden Jubilee in 2021. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.